I think first off, I think the talks so far today have been just super enlightening. Hopefully, this is just another one that's going to be informative for everybody. Um, we're going to be talking about resource optimization. We're going to talk about it specifically in the dimension of workload or application availability. And this is really a story of one of our customers. So you're going to see some intros to like customers and folks, and they're going to show up on video. But just to be clear, I'm going to do a little bit of an introduction to myself. We're going to introduce you to one of our customers who was so kind enough to participate in a public case study for us, and so that's what you're seeing. We're going to talk a little bit about their modernization journey. So we're not going to trip over all the details. We're specific to how they refactor their application, how they broke it up into microservices, how they deployed it into Kubernetes. But we're going to talk about very specific challenges around resource optimization when you're building a platform for tenants, where all of the tenants are using that platform in different ways and have different resource requirements. We'll talk a little bit about right-sizing at scale, some of the challenges around doing the right thing in terms of right-sizing those workloads in Kubernetes, especially at scale. We're talking about thousands and thousands, hundreds of thousands of containers and pods. And then we'll talk specifically about some of the outcomes that we were able to help our customer achieve specific to our right-sizing approach. So I'm going to start off with an introduction to myself. I've been talking a lot. You've been hearing a lot about me. Miko here referred to me as the man with tattoos. I've looked around the room. I appear to be the one with the most tattoos. You can refer to me as that the entire time. It doesn't bother me. But if you want to know my name is Erwin Daria. I'm the director of alliances at Stormforge. My background is in infrastructure engineering and operations. I started that a long time ago in the 90s, where because of Y2K, they gave everybody a job. And I faked my way through the entire experience, the entire industry, until about 10 years ago when I jumped into the vendor side. So that's a little bit about me. You'll see a little bit later, I've got a colleague of mine who is Yafti Makanen. Yafti, if you wouldn't mind raising your hand, he's joining me. He is a principal cloud architect, and he actually is the principal cloud architect that helped this one customer through a lot of these implementation, or I should say right-sizing challenges when it comes to our tool. So I'll preface everything by saying you're going to hear a story, you're going to hear some quotes from our customers via video, but if you have any questions, deep technical ones, if I can't answer them, I'm going to throw Yafti in front of that bus. So Acquia, who are they? Anybody heard of Drupal? That was a sarcastic question, but if you know Acquia, they are an enterprise-hosted Drupal platform. They were founded in 2007 by the people that effectively came up with Drupal, and then they have a hosted platform that allows customers to sign up and then get a Drupal environment and then build their applications or web applications on top of it. This is just a little bit of Jedi hand waving, but in terms of their kind of desires for modernizing their platform, prior to implementing Kubernetes, they had a very classical containers running on groups of virtual machines in the cloud type approach. You can argue whether or not Kubernetes is any different than that, but effectively, what they were looking for is to have a shared infrastructure, have a lot more elasticity around what scales, when it scales, and then not have to be in the business. I think Steve from Google mentioned today that everybody has a platform. If you have people running around doing things, and that's people as a platform, that might have been what they were going through before. And so moving to something where they have a little bit more autonomous elasticity was something that they were they were looking forward to doing. And of course, getting better utilization is always the promise of Kubernetes. Somebody put a Kubernetes graphic on the screen, and then there was oh, not bad, 2 out of 3. And I was like, 1 out of 3. But I digress. Okay. So let's fast forward to 2020. So they had this massive re-architecture exercise in terms of breaking up their application into a bunch of component microservices and how they were going to serve that. I'm going to gloss over a bunch of details, but effectively for our customer Acquia, every tenant is a namespace. Inside that namespace or a series of pods, inside each one of those pods is some number of containers. And so this is the architecture from an application standpoint that they decided to move forward with. So every time they get a new customer, they stamp out one of these and then they let them go. So quick show of hands, who relies on the developers to set the resource request, CPU, memory, request limits? So somebody's learned their lesson. How many of you set templates? So you have an artifact library with a bunch of whatever it is, manifest with predetermined things or Helm values, templates, or whatever, and that's how you set it. Or maybe somebody just randomly scream at me how they set resource requests. Nobody wants to randomly scream. Well, I mentioned a few different methods. None of those are going to be how this story ends. So if you see anything that's relevant, please don't hesitate to ask questions at the end. So you can imagine if you do that and you just templatize, you've got your small, medium, large, extra large kind of sets of templates, you might have some challenges. And so for our customer, there was quite a few. So first and foremost, they started off. I think Steve had earlier today had a really great graphic about as you're building your platform, you're finding like the lowest risk applications, you're moving them over, you're figuring out kind of either what breaks or what presents some challenges, and then you're kind of recursively going back and making sure that not only are you building more capabilities into the platform, but you're also maybe resolving some of the issues that you might have found. And I think this is exactly what Acquia went through in 2020, 2021. So with a portion of their customers migrated to the new Kubernetes platform, they had to pause because they were seeing a bunch of behaviors, scaling behaviors, auto-scaling behaviors that probably were not very good from a stability standpoint. And so when we initially started working with them in 2021, our primary lens that we look at these things through, resource optimization, is usually through like inefficiency. Like you have a ton of, like, stop me if you've seen this. You just got a lot of nodes in your cluster. You have a bunch of unschedulable pods because you hit some quota somewhere, and you have like the lowest utilization. You're looking at utilization, and utilization is like 12%. I'm seeing some head nods. But this wasn't the issue here for Acquia. So this was really more about, hey, we're having some issues with regard to how we set up things like HPAs. We're scaling on target CPU or memory utilization. We need to figure out how to size these things. And another person from Acquia that was then just kind of describing what the paradigm was at the time, which is they do some kind of benchmarking. They figure out what those sizes should be, what those buckets should be. But of course, if you start with a small template t-shirt size and your customer is deploying code into that environment, and for whatever reason their functions are consuming more resources, or their workload is consuming more resources, you need to be able to address for that. Now, some people don't address that in any, I'll say intelligent, I don't mean to be negative in that sense. They may just choose everybody gets an extra large, and then you get into those like really low utilization kind of scenarios. So with that, we'll start with our first video. Hopefully this works.
We don't own the customer's codes. We don't own the customer's codes. Every application is different. And we have tens of thousands of those applications running at any given time on these environments. There is no way we're going to be able to go engineering-wise and look at each one of them and say, size it this way this time, size it that way. We would have outages all over the place. And so we decided to automate those things so we could avoid and give our customers the best experience possible and moving over to this kind of environment.
Unmute. All right, quick show of hands. Like, does this resonate with anybody? Running into this issue and then having to find like this graceful way of addressing 10,000 snowflakes running on your platform in an efficient, time-efficient way. Okay, so I saw a few hands. That's very, very good. Okay, so let's take a little 10,000-foot tour, 10,000-foot high tour of right-sizing at scale. This is so at Stormforge we refer to optimization, resource optimization, as right-sizing. I'll go into kind of why we don't just talk about reduction. But let's revisit the architecture just to set the stage here, right? So we have the kind of broad, clunky representation of what a tenant might look like. And of course, for every single one of the containers that are deployed in every one of these pods, you have to have a set of CPU and memory requests. I'll pause at limits because this causes heartburn for some people. But for some, there may be additional parameters that you have to implement into the manifests. For Acquia, at their current size, this is 10,000 customers across 3 different environments. So they do dev, QA, and prod for every single one of their customers. As you can imagine, there's going to be different usages for every single one of them as they're going through developing code, testing it, and then releasing it to prod. And so this is 30,000 namespaces across dozens and dozens of clusters, over 300,000 containers, which if you multiply that by 4, if you're just looking at resource request, CPU and memory resource requests and limits, 1.2 million resource parameters that have to be tuned. I kind of share this as like just a data point to explain that this is why machine learning is incredibly important. So we heard from Tice at Google this morning about like ML ops, AI ops. Where is it? Are we a little ahead of the promise of AI ops? And I think our view at Stormforge is that if you narrow the scope sufficiently enough and you apply ML in a really intelligent way, then you can solve for very specific problems that have really large impact. And so we're not going to get into. You guys can ask questions of me. I'll be here the rest of the day if you want to get into the actual machine learning. But fundamentally, this is a machine learning problem. This is an automation problem. This is not enough eyes looking at graphs on dashboards and enough fingers typing on keyboards to solve it. So we make a tool, it's called Optimize Live. I'm not going to go into a demo or anything, but for the purposes of our customer, these are the things that our platform does. One, it analyzes time series metric data using machine learning. And so what we do is we scrape, we don't have to get into the nitty gritty, but basically every kubelet is running a cAdvisor metric endpoint. We have an agent that gets deployed into the cluster, and it just does auto discovery of every workload that's deployed into the environment, and it begins to scrape metrics. CPU usage, memory usage, requests, limits if they're there, and then a few other pieces of information in order to get a reasonable view of what the resource consumption is for any given set of pods or containers. Every container has its own machine learning model. So we train every single container. So every prediction that is made about the usage is based on the pattern, the usage pattern of that specific container. We don't sit here and try to like make a straw man and make guesses as to like, hey, this container looks like this one, and so we should size it just like this one. We're very specific about how the usage affects every single container. We make recommendations on what those values should be. The machine learning has logic that begins to recognize patterns in usage that infer things like seasonality. So we want to look at every minute of every hour of every day of every week, and every week within today, what we're doing is a 4-week look back period. But it allows us to make, when we do these predictions, we make these predictions based on a lot of this data, and we try to understand what that seasonality pattern is. So like if we see things like, the morning login time. When I say morning, it's dependent on time. Morning on the East Coast is different than morning on the West Coast. Morning is different in Europe, etc. Fundamentally, the output of all this machine learning has to be automatable. So we generate patches that change the values of the requests, and if in the case that you've configured limits, will change the limits as well. So, like, what are the key use cases for the machine learning? I think it's relatively obvious when we talk about waste reduction. So here, this is a screenshot of what you might see if you deploy our tool. The little green wavy pattern is usage for a particular container. The purple line that you see at the very top of the screen that kind of undulates is the total CPU requests, inclusive of the replicas that get generated when things peak and when things scale out. So this is just it has an HPA on it that has a 1 replica minimum, and I don't know what the max replicas is. And then the orange line that you see that's surfing that line, that's the machine learning making recommendations of what the vertical size of the pod should be. And the reason why it scales at the same time is because our machine learning is sensitive enough to recognize when there's an HPA, and will also modulate the target CPU or memory utilization so that the scaling pattern is exactly the same as it was. So what we don't want is that churn or that fighting that happens if you deploy something like a VPA with an HPA, where you have something scaling up and then you have something scaling down, and they're constantly thrashing back and forth. So the machine learning, again, is sensitive enough, sophisticated enough to recognize that. But more importantly, I think specific to availability are scenarios like this, where the red shaded area between the two lines, the purple and the orange line, which is the current requests and the recommended requests, is waste. But what's also really important is that the machine learning can find areas where there's risk for contention. So we want to identify these windows and then make recommendations about how to right size these pods. And this is, I think, critical to the use case of Acquia, where they have users that are deploying code into their environments. There's no control over what that code does, and it can exhibit itself in different ways. And in our case, specifically in the resource utilization of the pods themselves. And so we want to avoid these scenarios as well. So when we talk about right sizing, again, it's not just about reducing requests. It's about taking the CPU and memory resources that are available on the cluster on the nodes, and then taking them away from workloads that don't need them, and then giving them to the workloads that do. This is just an example of the fact that inside this pod, there are two containers and they have dramatically different requirements. And so you have this exporter container where the CPU needs to be reduced by a substantial amount, but then also the actual logic, the actual application container needs a pretty substantial increase. And you can see that there's like, turn down for CPU and memory for one, and then there's turn up for CPU and memory for the other. Again, this is something that if you're staring at the right dashboard, you can make these decisions all on your own. The problem is when you have thousands and thousands and thousands of them, and then you are running an operational platform where your end users, you have no say in what they're doing on the applications, and you want to be able to respond to those. Okay, so I mentioned patches. So our system generates patches. I'm showing you the UI. Again, in this particular case, we're showing a deployment that has an HPA. You don't have to tell us there's an HPA. We just auto-discover them all. We can read the values, and then we can, again, make recommendations about how those values should change up and down. All right, let's do this exercise one more time.
We were suggesting sizes of the environment, right? For example, because we would go out with, you got to give them some sort of size in the beginning just so they're up and running. Then Optimize Live would run in the background, collecting the data, and would make those recommendations for us. And so there was a couple of ways we even rolled that out, right? We started rolling this out in smaller clusters, smaller customers, smaller workloads, things like that, see how they kind of worked over time. Some of the concerns Will and I had about these things are the impact it would have on the backplane of the infrastructure. Is it making too many changes too often? And are we really starting to have struggles in the backplane, which causes other issues in the infrastructure? So that's why we were careful about rolling it out. So I mean, the use cases around properly sizing the requests of a pod for a customer based upon the use of that pod in that application at any given point in time. And so it would gather data in the background for 7 days. Then it would start coming up with recommendations. Then it would start actually actively changing that environment based upon that. Now we've started changing that going forward. So we started with just once a week we were making these changes, which we just started switching from because now there were other things before we wanted to move from once a week to twice a day. What we wanted to make sure of is that you didn't just make a change for the sake of making a change. If it was 1%, why are we changing anything? It's not going to do anything for anybody. But if it's 5% or more, or 10% or more, we would then actually make the change because that's actually something that is either going to be for the customer a better experience for their application, or for Acquia a cost savings which we can do something with. We don't do this just for cost savings. We've seen instances where it's increased our cost, right? And again, that's why I'm saying it's not just about cost optimization. It's about right-sizing the environment so you get what you expect from the application and services you're deploying and using.
All right, so Ed brings up a really interesting thing. We'll talk about, you'll hear from a few other folks at Acquia when it comes to things like churn. But what he's alluding to, and we can show you this at a demo if you want after this, is that as part of the guardrails for the machine learning that we've exposed, or at least for the automation for making these changes, you can set thresholds. And so we don't necessarily want to churn deployments just for the sake of churning them. You can tell the platform, hey, this isn't worth churning if it's only for 5%, 7%, one way or the other. I'm okay with going above requests and having a little bit of risk of contention, but obviously you want to find those scenarios where there's a significant change in the usage pattern and then make a corresponding change to the requests for those resources. let's go through some outcomes. So just to recap, right? In there, you'll hear from Ed specifically talking about the nines delivery, and I think Steve or somebody also had a really interesting point for like every nine you tack onto this is like a 10x fold in whatever the cost is. And so it's really great for us as a vendor and for our customer, and obviously as a story that we can achieve these things. So the total aggregate availability of all applications across all customers was increased pretty substantially. You'll hear him say more than 4 nines at this stage, I think, because they're still doing some analysis. But then on top of that, finding that you have an increase in efficiency as well, right? So that knowing that again, this is a crude hand gesture, but when you're making the requests, that they're not up here and the usage is down here, you're getting them to like be really, really close together. It's always a good metric for most folks. And then this was a project that they had earmarked 2 years plus to get completed. And we're really proud of this. The fact that they have a lot of smart people solving a lot of problems. Resource optimization is just one part of them that Stormforge was able to help them with. But knowing that they were able to increase their modernization velocity by moving all their customers from their legacy platform to their new one in 6 months instead of 2 years, I think is a pretty substantial achievement on all sides. Yeah. So the little cartoon in the lower hand corner, his name is Mel, and it's for ML. So if you ever see our propaganda, you'll know what his name is. Okay, so let's just revisit what Ed said in the last video, which is you'll remember 10,000 customers, 3 environments, 300,000 plus containers. They make changes every day, and they're working towards making changes twice a day. So the amount of machine learning that has to run to analyze all of the look back period to make a recommendation that's good, in this case, not only for the next hour, but the next 12 hours, is pretty substantial, which is why this platform has to be hosted. So I'm not going to go into why we can't run all of this in cluster, but if you tried, you would be running more of our software, more machine learning software on your cluster than you would be running your own. And so this is an incredible thing to have to do from a scale perspective, but we're really proud that we're able to be able to do this. All right, I might be done talking, and this might be all videos, but
one of the other benefits that we got was the reduction in churn. Because we had to pick kind of arbitrary settings for customers, if you try to do that and then you try to scale based on CPU, which is like the out of the box thing, if your requests are set poorly, your scaling is going to be very poor. And that can cause problems, particularly in our application. There are some workarounds for different workloads, but for our applications, bringing pods down occasionally can cause some customer pain. And when you do it as often as we were, it can lead to some issues. And so the combination of stopping scaling on CPU, which was only really possible because Stormforge could give us the right number for requests, that combination evened out our churn on the majority of our workloads substantially, which was good for a variety of reasons.
We've also increased the availability of our customers' applications by this move, which is typically not the case. When other companies move from EC2 nodes and legacy architectures to Kubernetes, they have a suffering of availability of the workloads running on them. And so we are operating at 4 nines or above at this point in this environment, where we were at 3 nines or below in the other environment, and still are today for that matter. I know Optimize Live had a hand in that because it allowed us to size the environments correctly and profile the applications over time.
All right. Can you guys hear me? Okay. So I'm here for questions. I don't know if anybody has any questions. That's about all we had. But just to call it out, if anybody wants to have hands-on, we do have a sandbox. So you don't have to deploy this into your own environment. We have a sandbox. You could take the URL here. We also have a self-paced workshop. So if you want to deploy our tool into like a kind environment right on your laptop, we've got sample apps that you can deploy so you can see it. So you don't have to necessarily feel like you got to deploy this into one of your down-level environments and kind of see it at scale. Yafty is here. I pointed him out, threw him under the bus at the beginning of this. I'm here. But yeah, if you have questions. Oh, sorry.
Hey, so how do you deal with like seasonal effects where like 7 days is not enough if like most of the traffic happens to come during like, Black Friday, Cyber Monday, or if it's like a company that sells Halloween stuff or something?
Yeah, that's a really great question. Right now, today, the product is, the look-back period is 28 days. We're looking at ways to extend that so that we can pick up signaling like a Black Friday or a Super Bowl Sunday. I can't divulge like specific details, but it is on the roadmap to continue to expand what that look-back period looks like so we can be more predictive about how those configurations should be in the future.
Thanks.
Any other questions?
Slam dunk.
Erwin, you said that you would run more of your machine learning workloads than your client workloads. How does the math in there in terms of, you being able to make money?
Well, so I think from our perspective, we have an expertise in running it at scale. And so like our environments, the ones that run the machine learning that generate the recommendations for our customers are so highly tuned for specifically that workload. Whereas in a customer workload, you have to optimize for a much broader set of end application use cases. We've done a bunch of optimization on our side too. We actually dog food our own. We right-size all of our own internal stuff as well. And so again, this isn't just like we've created a straw man. We actually very early on in the development of our platform, we used design partners, and we saw this live. Where we were providing, let's say in the interest of just a very simple explanation, maybe we provided 40% resource saving. So like basically total cluster size is reduced by 40% in just terms of number of nodes. At that point, we're also then consuming or returning back like another 20% just to run our software. So like we're like really buffering or mitigating our own effectiveness by doing that. And so again, that was the decision 2 years ago to really build this platform as a SaaS. And as we get more customers, we're finding that the scale of a lot of these customers, like they just really wouldn't want to be in the business of like managing what is effectively our backend on their backend. Because Acquia, as much as we love them and they're a public case study for us, they're not our largest customer. We have customers that are much larger than that.
Awesome. Thank you. All right. Any more?
Hello. CI workloads, jobs that are shorter and maybe not tied to a specific Kubernetes workload.
That's right.
Can you handle that? And sort of, is there any differences in the approach there?
So there are differences in the approach. I'm not trying to dodge the question. I'm trying to, let's take that offline. There are some things that we're looking at that are impending in terms of our releasing new features that are specifically for workloads like that. So like Spark jobs, that seems to be the one that comes to mind the most. But these are basically jobs that they are created, they run, they consume amount of resources, but then they go away before the 7-day kind of initial training period can be. And so we have, we're developing methods for tracking that over time and then still making recommendations. If we converse after this, maybe Yafty or myself can give you a little bit more details.
All right, last call.
Hello. What is the union between, or maybe the differences may be more interesting between the offering from StormForge versus some of the built-in GKE auto-scaling stuff or like AWS Carpenter? Because I can imagine a scenario for a customer is already using something like Carpenter. There may not be as many low-hanging fruit, and so I'm wondering, like, let's say someone's already using Carpenter, they're getting good, let's say, cluster efficiency from that. How much further can StormForge take them?
So that's a really great question. So for those of you, everybody familiar with like GKE Autopilot or things like Carpenter? Okay, great. So maybe for the audience and for the recording, right? Carpenter effectively is an intelligent cluster autoscaler. It uses the aggregate requests of pending pods to make a decision about what new nodes should be provisioned into the cluster. And the promise is that you're not just using a cookie cutter, M5 2XL everywhere for everything. You're getting much better bin packing density. Maybe not utilization density, but bin packing density, because you have a mismatch or a mix and match of different node sizes and shapes. What we find is that the total amount of resource, let's just call it waste, but we know that some go up and some go down, but like the total high level watermark of waste is generally in that 60 to 80% total wasted resources. We find that Carpenter can get half of that and StormForge can get the other half.
All right.
Told you, slam dunk.